We're given the function f of x equals 4x plus 2, and we want to find the inverse function. In addition, we want to state the domain and range of both f and f inverse. You can see that because this is a linear function that's increasing, its domain and range are both going to be the set of all real numbers. To find the inverse of this function, we first replace the f with y equals 4x plus 2. Then what we're going to do is interchange the roles of x and y. So we get x equals 4y plus 2. The idea there is that we interchange x and y when we find inverses, say when we did the ordered pairs. Now we want to solve this equation for y. We subtract 2 from both sides of the equation, and we get x minus 2 equals 4y, and then we divide both sides of the equation by 4, and we get y equals x minus 2 over 4. So the inverse function, f inverse of x, is 1/4 x minus 1/2 after dividing the 4 into both terms in the numerator. Now what we're going to do is verify that we did in fact find the correct answer. Oh, one other thing we want to do here, I forgot almost, is find the domain and range of this function. The domain is all real numbers. The range is also all real numbers, because the inverse is also a linear function that is increasing. So to verify our answers, what we have to do is show that f composed with f inverse, that is f of f inverse of x, gives me x. And I also have to show that f inverse composed with f, that is f inverse of f of x, also gives me x. I'll do one of these and leave the other to you. Let's do f composed with f inverse. That means I want f of x minus 2 over 4. And I choose this form because it's easier to work with algebraically. And that means that wherever I see an x in f, I want to replace it with x minus 2. So what I get there is 4 times x minus 2 over 4, and then plus 2. As you recall, f is 4x plus 2. Notice the 4's divide each other out, and I'm left with x minus 2, and then that plus 2. X minus 2 plus 2 is x. So this basically says that if you do f inverse to some variable x, and then do f to that, you end up right back where you started. That's why this check works. One other aspect of the problem is it asks us to graph each of these functions on the same plane, and the reason that we want to do that is just to verify that the graphs have the symmetry with respect to the line y equals x that we expect. So for example, if I graph f, for starters, that's f of x is what? 4x plus 2. So I have a y-intercept at 2, and then I use the slope to find an additional point on the graph. The slope is 4, so I could go left 1 and down 4 to find an additional point on the graph, and this is what I get. The other graph is f inverse, which is 1/4 x minus 2. Well, 1/4 x minus 1/2, I'm sorry. So my y-intercept is 1/2, and then I need to plot or use the slope to find one additional point. So I'll throw in my scale of 4. A slope of 1/4 means if I go up, if I go 1, 2, 3, 4 to the right, I go up 1, and I end up somewhere around there. And this is the graph that I obtain. And if you look closely, you can see that the graph does in fact have the symmetry that we expect with respect to the line y equals x.